Hello, this is Elizabeth Shumagawa from the Academic Support Center at Raritan Valley Community College. And I have here just a brief overview of the quadratic formula. So the quadratic formula is actually a very powerful equation that is used to solve quadratic equations. So we've looked at solving quadratic equations by factoring or by completing the square or by using the square root property. The quadratic formula can be used on any quadratic equation, and we can get answers for all of these equations. And without further ado, the quadratic formula, if we want to solve this equation for x, this ax squared plus bx plus c, is x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so if we have a quadratic equation, we can assign our a, b, and c's, and we can plug it into this equation. Now, when we talked about quadratic functions, we saw that we have different options, that there's different types of quadratic functions. We have some that don't ever touch the x-axis, some that touch the x-axis, and some that cross it twice. So there can be 1, 2, or no solutions. And the part of this formula that tells us that is this b squared minus 4ac, and that is called our discriminant. Our discriminant. Move this over here. And again, the discriminant is the portion that's underneath our square root function. So this is our b squared minus 4ac. So now if this is equal to 0, we have one solution. And that's this red graph over here. If it is greater than 0, we're going to have two solutions. And that's this green graph. Again, these can open up or down, but the point is that the red with one solution when our discriminant is equal to 0 touches once. Just touches and turns out our x-axis. And if it crosses and crosses back again, then it's 2. And if it's greater than 0, less than 0, we have no real solutions. Okay, so we can tell a lot just by looking at this discriminant portion of our quadratic function. Okay, so I wanted to go through just a couple of examples on how to use that. So I have a function down here. Now we may be able to solve this by factoring, but we certainly can use it solving our quadratic equation. And the first thing that I like to do is identify what my a, b, and c is. So my a is equal to 3. My b is equal to 1. There's no coefficient here, and it's applied, it's 1. And our c is equal to negative 2. So now that we have all of that identified, we can plug that into our quadratic equation. So negative b, that's going to be negative 1. Plus or minus the square root b squared, b is 1. And 1 squared is 1, minus 4 times a, which is 3, times c, which is negative 2. And all of this is over 2a, so 2 times 3. So this is plugging in. Now we have to simplify it. So we're just going to go through the basic arithmetic of solving this. Plus or minus the square root of 1. Negative 4 times 3 is negative 12 times negative 2 is negative 24. Is positive 24. Negative times negative is a positive, divided by 6. And now 1 plus 24 is 25, and the square root of 25 is 5. So this becomes 1 plus or minus 5, negative 1 over 6. And now negative 1 plus 5 is 4 over 6, which is equal to 2/3. And negative 1 minus 5 is negative 6 over 6, which is equal to negative 1. So we have x equals 3, 2/3, or x equals negative 1. So our discriminant here was positive, so we have two answers. Okay. Now you may want to say, you may want to think about, why do we want to solve this? Well, this is really valuable information. These are our x-intercepts, so we can actually write these as our x-intercepts. Steps are going to be 2/3, 0, and negative 1, 0. Okay, so that's our ordered pairs for our x-intercept. Our y-intercept for this equation, if we plug 0 in, we're going to get 0 plus 0 minus 2. So it's going to be 0, negative 2. So we're trying to solve these quadratic equations. It gives us information about the function. So here we had this is equal to 0, but if we had f of x is equal to 3x squared plus x minus 2, and we wanted to find the x-intercepts, well, we'd set that equal to 0. Our x-intercept is where y equals 0, and then we can use the quadratic equation to find our x-intercept. We can find our y-intercept. And in other lessons, we talked about finding the vertex. So we can find the vertex, and then we can put all of that information together to get a really good idea about what the graph of the function looks like. Okay, this was an example where we had whole rational numbers. Sometimes, and we probably could have solved this by factoring if we worked at it. Sometimes we have equations that we can't necessarily solve by factoring. I just want to move this guy. Sorry about this. Come on. Down over here. Okay. Sometimes we have equations that we can't solve necessarily by factoring. And so this is where the quadratic equation becomes really powerful. Again, here we're going to assign a is equal to 3, b is equal to 4, c is equal to negative 2. And now we can plug this into our quadratic equation again. We have negative b, so that's negative 4, plus or minus the square root of b squared. Well, b is 4, so 4 squared is 16, minus 4 times a is 3, times c is negative 2, all over 2 times a, which is 3. So these are going to be our x values. Again, x is equal to negative 4. We're just going to go through the steps of simplifying this. Square root of 16 minus, we'll put 16. 4 times 3 is 12, times negative 2 is negative 24, and negative is positive. This becomes plus 24. All over 2 times 3 is 6. Okay? 16 plus 24 is 40. Now we can't take 40 is not a perfect square, so we're going to end up with a rational expression, but we can simplify this a little bit further. We can write this 40 as the square root of 4 times the square root of 10. And the square root of 4 is 2. So this becomes negative 4 plus or minus 2 square roots of 10 over 6. And one more step to simplify this as far as we can. We're going to divide everything by 2. 4 divided by 2 is 2, plus or minus 2 divided by 2 is 1, so we just have square root of 10. 6 divided by 2 is 3. This is equal to x. So this is our final answer. We have two solutions to this problem. It's x equals 2 plus the square root of 10 divided by 3, and negative 2 minus the square root of 10 divided by 3. And this is also the x-intercept, so we can write the x-intercept. are equal to -2 plus or minus the square root of 10 over 3, comma 0. You can represent both of the intercepts in that manner. So, so you can see here, you would never have found that solution with factoring, but you can get a solution and you can actually plug it into your calculator and get an approximate value for it. So, again, the Academic Support Center, we are here to help you. I'm going to do one more example. I think I'm going to run out of time here. So I'm going to leave that here, but I'm going to do an example with complex solutions. So where our discriminant is less than 0. And that will be a part B to this discussion. But our quadratic formula is -b plus or minus the square root of b squared minus 4ac all divided by 2a. If you have further questions just on the application of this formula, please do not hesitate to reach out. The Academic Support Center is open for online tutoring during the COVID-19 shutdown and in person at the Academic Support Center on campus once things are back to normal.